Welcome to The Explainer. Today, we're diving into what could be the biggest leap forward in cancer treatment yet, a universal vaccine. I know, it sounds totally backwards, right? But stick with me, because today we're exploring this exact idea. It's a revolutionary shift in cancer treatment that starts with this counterintuitive thought, and it could change absolutely everything we thought we knew about fighting this disease.
So, to really get where we're going, first we need to look at where we are now. We're at the current peak of cancer therapy, personalized vaccines. I mean, they're a marvel of modern medicine for sure. But as you're about to see, they come with some really serious real-world problems.
Creating a personalized vaccine, well, it's an incredibly complex process. It all starts by taking a tiny piece of a patient's tumor. Then, scientists sequence its entire genetic code to hunt for these unique little flags called neoantigens. And from there, they have to design and build a custom mRNA vaccine completely from scratch, just for that one person. And that whole custom manufacturing thing, it is not fast. We're talking 8 to 12 weeks. That's a critical delay, a window where aggressive cancers can keep growing and spreading. By the time the vaccine is finally ready, the cancer might have changed.
Oh, and then there's the cost. With a price tag that can soar past $150,000 per patient, this cutting-edge therapy is, let's be honest, just not accessible for most people on the planet.
And here's the real kicker. Even after all that time and all that money, these vaccines often just don't work against the most common tumors. See, about 70% of solid cancers are what scientists call immunologically cold. They're essentially wearing camouflage, invisible to the immune system. So a super-specific, targeted vaccine has no idea what to attack.
So, these huge challenges, time, cost, and just plain effectiveness, have really forced researchers to think way outside the box. And that's led to a radical new approach, something they're calling a third paradigm in cancer immunotherapy.
Instead of trying to target the cancer directly, researchers came up with this stunning new idea. What if a vaccine's only job was to wake up the patient's own immune system, to just create enough chaos to get it to see the cancer and fight it on its own terms? And this really highlights that fundamental shift in strategy, doesn't it? We're talking about moving from a bespoke, slow, and crazy expensive model to one that is universal, ready to go off the shelf, and affordable for so many more people.
So, how in the world does a non-specific vaccine manage to fight a very specific tumor? Well, the secret is this powerful, naturally occurring biological process that scientists are now figuring out how to harness.
It's a process called epitope spreading. And here's the best way to think about it. The immune system gets trained on one little target, and then it starts recognizing other, related targets all by itself. It's like a chain reaction. The vaccine starts one small, controlled fire. And by studying that fire, the immune system learns how to hunt down the much bigger hidden threat all on its own. Think about it like this. A universal vaccine doesn't try to go after a huge criminal network and identify every single member one by one. I mean, that would be way too slow, way too complicated.
Instead, it just creates a loud public disturbance right outside their hideout. And all that commotion forces the hidden tumor antigens out into the open, making the entire tumor visible to the immune system, maybe for the very first time.
Okay, so this cascade is the key to the whole thing. The vaccine's mRNA is basically a fire alarm. It goes off, triggers this intense immune response, and that turns a cold, invisible tumor into a hot, inflamed one. And this creates this amazing self-reinforcing loop. The first attack kills a few tumor cells, which releases more of its unique antigens. And that teaches the immune system to attack even harder. It's a snowball effect, all kicked off by one simple, non-specific trigger. It's brilliant.
This incredibly clever mechanism has revolutionary implications, not just for how we treat cancer, but for who can be treated. It completely challenges the whole business model of high-cost precision medicine and opens the door to real global health equity.
I mean, just look at them side by side. The potential of the universal off-the-shelf approach is just staggering. We're not talking about a little improvement here. We're talking about a potential 100-fold cost reduction and a vaccine that's ready to go immediately.
And this is why that matters so much. It could finally democratize access for this 70% of cancer patients living in low and middle-income countries. Right now, they're pretty much shut out from the most advanced treatments. This could change that.
So what does this all mean for the future of oncology? We are potentially looking at a complete transformation of how we manage and maybe even prevent cancer.
And the timeline here is moving incredibly fast. The first universal mRNA vaccines, they're projected for approval in just the next couple of years. This paves the way for a future where stage 4 cancer might not be a death sentence,
but something you manage as a chronic condition. Kind of like managing diabetes or high blood pressure.
And the ultimate vision goes beyond just treating cancer. The goal is to shift to proactive precision interception, using these vaccines to stop cancer in high-risk people before it can even get a foothold. Just imagine that mental shift, from fearing a diagnosis to being empowered with preventative control over your own health.
This massive shift from personalized to universal vaccines isn't just about a new tool. It's about a new kind of hope. It really leaves us with a final, provocative thought. Are we on the verge of a future where cancer is a preventable, manageable disease for everyone, everywhere?